Let's do Brahmanad. Om. Om. Santi. 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 Swasta. Good morning student. Previous classes I discussed about the hybridization, condition for hybridization, characteristics, types of hybridization, and finally I discussed about individual hybridization like your sp, sp2, sp3 like this. Now I am going to discuss about the molecular orbital theory. It is a very important long question. At first I will discuss about the salient feature of molecular orbital theory. First point is molecular orbital are formed by the linear combination of atomic orbital of comparable energy. This means that atomic orbital undergoes linear combination and form the molecular orbital. Suppose पिले हमें दुईटी atomic orbital नेले ताका हमें linear combination करिबा आउ करी हमें molecular orbital पाइबा. Second point, the number of molecular orbital formed is equal to the number of atomic orbital. Suppose हमें 2 atomic orbital नेले जाफଳରେ ଆମେ 2 molecular orbital पाइबा. Third point, when 2 atomic orbital of 2 atoms combine to form 2 molecular orbital, one of them has lower energy and greater stability is called bonding molecular orbital, and another with a higher energy and less stability is called anti-bonding molecular orbital. Suppose हमें दुईटी atomic orbital लेले ताको हमें linear combination कले. Linear combination कला पारे पिले दुईटी molecular orbital मिलिबो. से दुईटी molecular orbital भितर गोटे more stable less energy आ गोटे less stable more energy. Suppose जदि पिले हमें एटा को हमें energy level कहिबा आ ये होची गोटे atom रो atomic orbital. This is atomic orbital of another atom. When these two atomic orbital undergoes a linear combination, then 2 molecular orbital are formed. Among the 2 molecular orbital, one molecular orbital is called bonding molecular orbital. Another molecular orbital is called anti-bonding molecular orbital. Suppose this is the energy level of these 2 atomic orbital. This bonding molecular orbital having less energy, more stability. This anti-bonding molecular orbital having more energy and less stability. Look at that, this anti-bonding molecular orbital is present above these 2 atomic orbital. On the other hand, this bonding molecular orbital present below these 2 atomic orbital. This energy level indicate the energy of bonding molecular orbital. This energy level indicate the energy of the anti-bonding molecular orbital. From this diagram, it is clear that the bonding molecular orbital having less energy than the atomic orbital. On the other hand, the anti-bonding molecular orbital having more energy as compared to the 2 atomic orbital. Next point, the molecular orbitals combine the nuclei of all the bonded atom. ये जो molecular orbital गुड़ा अच्छी से molecular orbital कौन करती ना bonded atom रा nucleic को combine करी रखी थांती. Next point, the shape of molecular orbital depends upon the shape of atomic orbitals. In this diagram, look at that. There are two atomic orbitals are present. Here also two molecular orbitals are present. From this, it is clear that the number of atomic orbitals is equal to the number of molecular orbitals. Suppose I want to draw the molecular orbital diagram of oxygen molecule. Then how can I draw the molecular orbital diagram of oxygen? The electronic configuration of oxygen is your 1s2, 2s2, 2px, 2p, y1, 2pz1. At first, draw the energy level. This is your energy level. This indicates that the energy goes on increases from bottom to top. Take two oxygen atom. This is your oxygen atom 1. This is your oxygen atom 2. At first, take the 1s orbital. Suppose this is your 1s orbital. तमे चाहिले ताको एमती स्क्वायर रूपे इंडिकेट करि पारो भाले सर्कल रूपे मध्य इंडिकेट करि पारो. Here also 1s orbital of this oxygen atom is also present. Now these two atomic orbital undergoes linear combination from two molecular orbital like this. These two are said to be molecular orbitals of oxygen molecule. This is your bonding molecular orbital. This bonding molecular orbital always present at the bottom of these two atomic orbital. This is your said to be antibonding molecular orbital. This antibonding molecular orbital always present above these two atomic orbital. Next atomic orbital is your 2s. Here also 2s atomic orbital is present. This is your 2s. This is your 2s. Now these two atomic orbital combine with each other and form two molecular orbital.
Next is your 2p subshell.
There are three atomic orbital present like this.
पिले मन रख 2p रो तीनोटी ऑर्बिटल अछि.
तीनोटी ऑर्बिटल केबे लेले तीनोटी सिग्मा बॉन्ड तयारी करि परिबे नाही. सेति भितरो गोटिए सिग्मा बॉन्ड हो अन्य दुईटी पाई बॉन्ड फॉर्मेशन करिवो. आमे जानि जे पिले पाई बॉन्ड is less stable than sigma bond. So the pi bonding molecular orbital having more energy than sigma bonding molecular orbital. गोटे पॉइंट है मन रख पिले गोटे बॉन्डिंग मॉलिक्यूलर ऑर्बिटल जेतिकी स्टेबल से अनुसार तार एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल सेतिकी अनस्टेबल. एटा देख पिले तीनोटी एटॉमिक ऑर्बिटल अछि. एठारे मध्ये तीनोटी एटॉमिक ऑर्बिटल अछि. टोटली 6 एटॉमिक ऑर्बिटल अछि. तेनो हमको 6 मॉलिक्यूलर ऑर्बिटल तयारी करबा पड़िबो. से 6 मॉलिक्यूलर ऑर्बिटल भीतर पिले तीनोटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल आउ तीनोटी एंटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल. ए तीनोटी बॉन्डिंग मॉलिक्यूलर ऑर्बिटल मध्यरु गोटिए सिग्मा बॉन्डिंग मॉलिक्यूलर ऑर्बिटल आउ दुईटी पाई बॉन्डिंग मॉलिक्यूलर ऑर्बिटल. ए तीनोटी antibonding molecular orbital ମଧ୍ୟରୁ ଗୋଟିଏ sigma antibonding molecular orbital ଆଉ ଦୁଇଟି pi antibonding molecular orbital। এই 6টি molecular orbital ভিতରୁ পিলে sigma bonding molecular orbital is more stable, so it has less energy। So here I can draw the sigma bonding molecular orbital like this। तमको किस संभव कहला गोटे bonding molecular orbital जेतिकी stable तार other hand race सेतिकी unstable। So obviously the anti-bonding sigma molecular orbital having more energy as compared to the other। This is your said to be sigma bonding molecular orbital, this is your said to be sigma anti-bonding molecular orbital। There are two pi bonding molecular orbital and also there are two pi anti-bonding molecular orbital। Among these two pi bonding molecular orbital is more stable as compared to these two pi anti-bonding molecular orbital। Remember an important point, these two pi bonding molecular orbital having same energy and these two pi bonding molecular orbital present at the same energy level। Similarly, these two pi anti-bonding molecular orbital having same energy, these two pi anti-bonding molecular orbital must be present at the same energy level। But remember, these two pi bonding molecular orbital must be present below this atomic orbital and these two pi anti-bonding molecular orbital present above these atomic orbitals। That means here I can draw two pi bonding molecular orbital, here I can draw two pi anti-bonding molecular orbital। Remember an important point, the bonding molecular orbital is written without star mark, on the other hand the anti-bonding molecular orbital is written by the help of star mark। ये जो molecular orbital अच्छी तरह नाम कौन हो बिले sigma 1s, ये हो बिले sigma molecular orbital, it is made by 1s orbital, so the name of this molecular orbital is sigma 1s। This is your anti-bonding molecular orbital, this anti-bonding molecular orbital also made by these two atomic orbital, so the name of this molecular orbital is also sigma 1s। Since it is an anti-bonding molecular orbital, so it is bound to keep the star mark here। That means this molecular orbital is called sigma 1s, this molecular orbital is called sigma 1s star। This molecular orbital is made by two 2s atomic orbital and it is also a sigma molecular orbital, so the name of this molecular orbital is sigma 2s। This molecular orbital is considered as the anti-bonding molecular orbital and it is made by this 2s atomic orbital। This is your sigma molecular orbital and the name of this molecular orbital is sigma 2s star। This p subshell having 3 atomic orbital, that is your 2px, 2py, 2pz। Here also 3 atomic orbital are present, this is your 2px, 2py, 2pz। Suppose I want to form this sigma molecular orbital by the help of 2px, then the name of this molecular orbital is your sigma 2px। This is your corresponding anti-bonding molecular orbital. So the name of this anti-bonding molecular orbital is your sigma 2px star. The other two orbitals are used for the formation of pi bonding. Suppose a student wants to form this sigma molecular orbital by the help of 2py, then the name of this sigma molecular orbital is your sigma 2py, and this is your said to be sigma 2py star. And the rest two atomic orbitals, that is your 2px and 2pyz, are used for the formation of pi bonding molecular orbital. Here 2px is used for the formation of sigma molecular orbital. So the other two atomic orbitals, that is your 2py and 2pz, are used for the formation of pi bonding molecular orbital. So these pi bonding molecular orbital are named as pi 2py. This is your said to be pi 2pz. This anti-bonding molecular orbital having name pi star 2py. This anti-bonding molecular orbital is named as pi star 2pz. Look at that. In this molecular orbital diagram, there are 10 atomic orbitals are present, such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Also there are 10 molecular orbitals are present, such as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. From this it is clear that the number of atomic orbital is equal to the number of molecular orbital. Next salient feature is each molecular orbital can accommodate maximum of 2 electrons. This rule is called Pauli's exclusion principle. Next point is, in degenerate molecular orbital, the pairing of electron cannot take place unless each degenerate molecular orbital is half-filled. That is your called Ohm's rule. Degenerate orbital means कि जो orbital गुड़ाकर एनर्जी सेम थिबो ताको आमे degenerate orbital बोली कहि थाओ. फॉर एग्जांपल देखो कि एठारे 2px 2py 2pz एमानकर एनर्जी समान, तेणु ए तीनटा को आमे degenerate orbital बोली कहि परिबा. एठा देखो कि दुईटी पाई बॉन्डिंग मोलेकुलर ऑर्बिटल अछि, सेमानकर एनर्जी सेम, तेणु ए दुईटा को परस्पर degenerate orbital बोली कहि परिबा. Similarly, एठारे पिले मध्य दुईटी एंटी बॉन्डिंग मोलेकुलर ऑर्बिटल अछि, सेमानकर एनर्जी मध्य सेम, तेणु एमानो केस रे पिले ओम्स रूल अप्लाई हबो. तामाने एमाने प्रथमे सिंगली फील्ड हेबे, तापरे जाईकी डबली फील्ड हेबे. Next point is, the molecular orbital are filled up by the electron in the increasing order of their energy. This is called above principle. Among these molecular orbital, the sigma 1s molecular orbital having less energy, so it is filled first. The order of arrangement of the molecular orbital according to the increasing order of their energy is written like this: sigma 1s having less energy than sigma 1s star, sigma 1s star having less energy than sigma 2s, sigma 2s having less energy than sigma 2s star, sigma 2s star having less energy than sigma 2px, sigma 2px having less energy than pi 2py, pi 2py having same energy with the pi 2pz. Both these two pi bonding molecular orbital having less energy than pi 2py star, pi 2py star having equal energy with the pi 2pz star. Both these anti-bonding molecular orbital having more energy than this bonding pi molecular orbital. These two pi antibonding molecular orbital having less energy than sigma to px star. This energy order is written for all molecules except some special molecule. These special molecules are hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. For these molecules, the energy order is like this: sigma 1s smaller than sigma 1 star, sigma 1s star less than sigma 2s, sigma 2s less than sigma 2s star, sigma 2s star less than pi to py, which is equal to pi to pz. That means there is the change. Now these two pi bonding molecular orbital having less energy than sigma to px, and this sigma to px having less energy than these two pi antibonding molecular orbital. These two pi antibonding molecular orbital having less energy than this molecular orbital. टिके बिले चेंज हबो सिग्मा टू px ए जो दुईटी पाई बॉन्डिंग मॉलिक्यूलर ऑर्बिटल पूर्वरु सब मॉलिक्यूल केस रहइबो किंतु एई मॉलिक्यूल मानक केस रे कोन हबो बिले सिग्मा टू px रो एनर्जी एई जो दुईटी पाई बॉन्डिंग मॉलिक्यूलर ऑर्बिटल अछि ताकटारो अधिक हबो. काहे एमती हला यार कारण में नाइट्रोजन मॉलिक्यूल रो मॉलिक्यूलर ऑर्बिटल डायग्राम ड्रा करलको पडिबा. नाइट्रोजन परि मध्य अन्य जो मॉलिक्यूल अछंती समान केस रे मध्य एमती हबो किंतु अदर मॉलिक्यूल केस रे कोन हबो बिले सिग्मा 1s लेस देन सिग्मा 1 स्टार लेस देन सिग्मा 2s, सिग्मा 2s लेस देन सिग्मा 2s स्टार, सिग्मा 2s स्टार लेस देन सिग्मा 2px, sigma 2px less than pi to py, which is equal to pi to pz. These two bonding pi molecular orbital having less energy than these two pi antibonding molecular orbital. These two pi antibonding molecular orbital having less energy than sigma to px star. हाइड्रोजन हीलियम लिथियम बेरिलियम बोरॉन कार्बन नाइट्रोजन केस रे टिके चेंज हबो अन्य समस्त केस रे एई ऑर्डर फॉलो करिवो. नेक्स्ट पॉइंट इज द इनर ऑर्बिटल ऑफ एन इंडिविजुअल एटम पार्टिसिपेट इन द फॉर्मेशन ऑफ मॉलिक्यूलर ऑर्बिटल. देखो बिले एठारे 1s 2s एटॉमिक ऑर्बिटल मध्य पार्टिसिपेट करछन्ती फॉर द फॉर्मेशन ऑफ मॉलिक्यूलर ऑर्बिटल. किंतु हमें हाइब्रिडाइजेशन पढेला समय रे कहिथिले वैलेंसी सेल रे दिबा एटॉमिक ऑर्बिटल ही बॉन्ड तयारी करे पार्टिसिपेट करि परिबे किंतु देखो बिले एठे 1s 2s इनर ऑर्बिटल मध्य पार्टिसिपेट करूछंती. नेक्स्ट पॉइंट इज द कंबाइनिंग एटॉमिक ऑर्बिटल आर कंप्लीटली यूज्ड अप ड्यूरिंग द फॉर्मेशन ऑफ मॉलिक्यूलर ऑर्बिटल. जति कि बिले एटॉमिक ऑर्बिटल तिबे समस्त एटॉमिक ऑर्बिटल यूज करा फॉर द फॉर्मेशन ऑफ मॉलिक्यूलर ऑर्बिटल्स. Next point is greater the overlap of two combining atomic orbital, lower will be the energy of the bonding molecular orbital. Because we know that greater is the overlapping of the two combining atomic orbital, more is the stability. Again, we know that more is the stability, lesser is the energy. So, greater the overlapping, lower will be the energy, and higher is the stability. In case of bonding molecular orbital, the overlapping is more. That's why the bonding molecular orbital is more stable as compared to the anti-bonding molecular orbital. As a result, the bonding molecular orbital having less energy as compared with the anti-bonding molecular orbital. These are the some points related to the salient feature of molecular orbital theory. Molecular orbital theory is shortly called MOT, and these diagrams are also called MOT diagram. Next, I want to draw the complete molecular orbital diagram for oxygen molecule. There are 8 electrons present in one oxygen atom. The electrons are present like this. Here 2 electron, here also 2 electron, here 2 electron, here 1 electron, here 1 electron present. Like this oxygen atom, here also 2 electron, here also 2 electron, here 2 electron, here 1 electron, here 1 electron are present like this. There are 2 oxygen atoms, that means there are 8 into 2, that is 16 electrons are present in 2 oxygen atoms. These 16 electrons must be present in the molecular orbital of oxygen molecule. Among the 16 electrons, it is bound to give here 2 electrons. Among the 16 electrons, 2 electrons are for sigma 1s orbital. 2 electron sigma 2s को देला परे और रहला बेले 14 electron. 14 electron मध्यरो sigma 1s स्टार को 2 electron दिया हो. ताबरे रहबा बेले आउ 12 electron. 12 electron रो 2 electron sigma 2s orbital को दिया हो. और रहबा बेले 10 electron. 10 electron भितर बेले 2 electron sigma 2s स्टार को दिया हो. और रहला बेले 8 electron हमको तळु ऊपर को नहीं की जीवा पड़िबो. 8टा इलेक्ट्रॉन भितर 2टी इलेक्ट्रॉन सिग्मा 2px को दिया हो. और रहबा बेले 6टी इलेक्ट्रॉन. 6टी इलेक्ट्रॉन भितर फर्स्ट मान को हाफ फील्ड करा हो, सेति पय 2टी इलेक्ट्रॉन यूज हो. 2टी इलेक्ट्रॉन हाफ फील्ड पय यूज कला परे और रहबा बेले 4टी इलेक्ट्रॉन. 4टी इलेक्ट्रॉन जेहेतु बळी की रहछि तेणु मान को फुलफिल करा हो. फुलफिल करिया पय आउ 2टी इलेक्ट्रॉन हम यूज करिया पड़िबो. 2टी इलेक्ट्रॉन फुलफिल करबा परे और रहबा बेले नर 2टी इलेक्ट्रॉन. से 2टी इलेक्ट्रॉन को हमें एठे गोटे दबा पड़िबो, एठे गोटे दबा पड़िबो. कोनोसी रूपे ए ऑर्बिटल को दीटा दे ए ऑर्बिटल खाली रखिबो नाही, कारण हमर ओन्स रूल कहछि हाफ फिल हैला परे ही फुलफिल होबो. यदि हमको इलेक्ट्रॉन कॉन्फिगरेशन ड्रा करिया पड़िबो ताल कोन लिखिया सिग्मा 1s2 सिग्मा 1s स्टार 2 सिग्मा 2s2 सिग्मा 2s स्टार 2 सिग्मा 2px 2 pi 2py 2 pi 2pz 2 pi star 2py 1 pi star 2pz 1. ए जो डायग्राम रो आमे कोन बेनिफिट पाइबा बेले ए डायग्राम रो आमे बॉन्ड ऑर्डर पाइ परिया बेले ओटे मॉलिक्यूल रो स्टेबिलिटी विषय रे कहि परिबा, तार मैग्नेटिक कैरेक्टर विषय मध्य बेले कहि परिबा. ए डायग्राम द्वारा आमे एति जिंस आमे बेनिफिट पाइ थाओ. बॉन्ड ऑर्डर पाइबा पय बेले आमे ओटे फार्मूला यूज करिबा. बॉन्ड ऑर्डर इक्वल टू number of bonding electron minus number of anti-bonding electron divided by 2. Nb माने number of bonding electron, Na माने number of anti-bonding electron. पहले bonding molecular orbital है पहले sigma 1s और है sigma 2s sigma 2px pi 2py pi 2pz एमाने लेबले बॉन्डिंग मॉलिक्यूलर ऑर्बिटल. ए बॉन्डिंग मॉलिक्यूलर ऑर्बिटल ले केतोडी इलेक्ट्रॉन अछि पहिले देखा 2 plus 2 that is 4 4 plus 2 6 6 plus 2 8 8 plus 2 10. ता माने Nb हला पहिले 10. एंटी बॉन्डिंग के लेबले सिग्मा 1 स्टार सिग्मा 2 स्टार pi 2py star pi 2pz star. एमान के बारे इलेक्ट्रॉन केतोटा अछि पहिले 2 plus 2 4 4 plus 1 5 5 plus 1 6 तेनो एने हला पहिले नर 6. यदि आमे ऑक्सीजन मॉलिक्यूल रो इक्वल टू कोन बोले NB माने 10 NA माने 6 तेणु 10 - 6 डिवाइड बाय 2 तामे आसी बोले 4/2 इक्वल टू 2 तेणु बोले हमें बॉन्ड ऑर्डर इन ऑक्सीजन मॉलिक्यूल इक्वल टू 2 कहबा बॉन्ड ऑर्डर 2 कहबा अर्थ डबल बॉन्ड को बुझेबो तेणु बोले ऑक्सीजन ऑक्सीजन भितरे डबल बॉन्ड अछि बोली ए मॉलिक्यूलर ऑर्बिटल डायग्राम रो प्रूव होला इफ द बॉन्ड ऑर्डर इज 1 then it indicates single bond if the bond order is 2 then it indicates double bond if the bond order is equal to 3 then it indicates triple bond by the help of this formula we can able to find out the bond order of a molecule or molecular ions next is the stability remember an important point if the number of bonding electron is greater than number of antibonding electron then the molecule is more stable remember another important point if NB equal to NA then the molecule is stable in the atomic state if NB is smaller than NA then the molecule is completely unstable. In case of oxygen molecule, NB equal to 10, Na equal to 6. Look at that. Here NB greater than Na, so oxygen molecule is more stable. Next is your magnetic character. Especially by the help of molecular orbital diagram, we can explain two magnetic property. One is your डायमैग्नेटिक अनदर इज योर पैरामैग्नेटिक यदि ए जो मॉलिक्यूलर ऑर्बिटल भितर यदि कोनोसी गोटी मॉलिक्यूलर ऑर्बिटल सिंगल इलेक्ट्रॉन कैरी करथिबो ताले से मॉलिक्यूल को कंप्लीटली हमें पैरामैग्नेटिक बोली कहबा यदि समस्त मॉलिक्यूलर ऑर्बिटल जो इलेक्ट्रॉन अछि समस्त दुई दुईटी लेखा रखिसंदी ताले हम ताको डायमैग्नेटिक कहबा एटलीस्ट गोटी मॉलिक्यूलर ऑर्बिटल यदि गोटी इलेक्ट्रॉन रखिदे माने सिंगल फील्ड हेतिबो तार तक हमें पैरामैग्नेटिक कहबा देखो बिले एठारे जो मॉलिक्यूलर ऑर्बिटल अछि कंप्लीटली फील्ड ये भी कंप्लीटली फील्ड ये भी कंप्लीट फील्ड ये वाला कंप्लीटली फील्ड दिस मॉलिक्यूलर ऑर्बिटल इज आल्सो कंप्लीटली फील्ड दिस मॉलिक्यूलर ऑर्बिटल आल्सो कंप्लीटली फील्ड but listen here two molecular orbital are present and the two molecular orbital are not completely filled एठारे दुईटी मॉलिक्यूलर ऑर्बिटल अछंती किंतु से माने सिंगल फील्ड ता माने सिंगल इलेक्ट्रॉन वाला आसिला तेनो ऑक्सीजन होची पिले ओटे पैरामैग्नेटिक इन नेचर पिले आमे जो मैग्नेटिक कैरेक्टर कहला समय रे आमे एम्प्टी ऑर्बिटल को ध्यान देई न थाओ फाइनली I concluded that the bond order of oxygen molecule equal to 2 since the number of bonding electron is more than the number of antibonding electron so the oxygen molecule is more stable since there is a presence of unpaired electron so the oxygen molecule is paramagnetic in nature next I want to explain about the molecular orbital diagram for nitrogen molecule हमें जानी जे बिले हाइड्रोजन हीलियम लिथियम बेरिलियम बोरॉन कार्बन एंड नाइट्रोजन पाई ये होची एनर्जी ऑर्डर अदर मॉलिक्यूल मानक पाई ये होची एनर्जी ऑर्डर सिंस आई वांट टू ड्रॉ द molecular orbital diagram of nitrogen molecule so it is bound to follow this order ये जो दीटा ऑर्डर अछि बिले दीटा ऑर्डर भितर डिफरेंस होछि बिले सिग्मा 2px रो एनर्जी लेवल हाइड्रोजन हीलियम लिथियम बेरिलियम बोरॉन कार्बन नाइट्रोजन केस रे सिग्मा 2px रो एनर्जी पाई 2py और पाई 2pz रो एनर्जी थारो अधिक होछि तार कारण होला बिले साइज हाइड्रोजन हीलियम लिथियम बेरिलियम बोरॉन कार्बन नाइट्रोजन केस जे देखिबा एमानकर बिले साइज कम होई थाए जेते एमानकर साइज कम होई थाए बिले तेनो ई जो सिग्मा 2px और सिग्मा 2s स्टार मॉलिक्यूलर ऑर्बिटल पूरा पाखा पाखी रही थांते एक्चुअली नियम दृष्टिकोणରୁ सिग्मा 2s स्टार ପରେ सिग्मा 2px ରହିବା କଥା କିନ୍ତୁ ଏମାନଙ୍କର ସାଇଜ କମ ହେବା ଯୋଗୁ सिग्मा 2px ଆଉ सिग्मा 2s स्टार ମଧ୍ୟରେ रिपल्सन होची जा फल रे बिले सिग्मा 2px रो एनर्जी बढ़ुची एनर्जी बढ़िवा जोगु कोन होची बिले ना सिग्मा 2px रो एनर्जी पाई 2py और पाई 2pz ऊपर को चली जाउची तेणु आमे कोन करिया बिले एठारे आमे दुईटी पाई मॉलिक्यूलर ऑर्बिटल रखिबा और एठारे आमे कोन रखिया बिले गोटिए सिग्मा मॉलिक्यूलर ऑर्बिटल रखिबा और से सिग्मा मॉलिक्यूलर ऑर्बिटल नाम कोन बिले सिग्मा 2px और एठारे जो दुईटी पाई मॉलिक्यूलर ऑर्बिटल अछि ताना कोन लिखा बिले हमें पाई 2py आना कोन लिखा बिले पाई 2pz now I can write here nitrogen atom here I can write nitrogen molecule here I can write nitrogen atom now I can arrange the electron in the different types of orbitals. The atomic number of nitrogen is 7, so there are 7 electrons in one nitrogen atom. There are 2 nitrogen atoms, so the total number of electrons present in the atomic orbitals of 2 nitrogen atoms are 7 into 2, that is 14. I can arrange the 7 electrons present in one nitrogen atom like this. Here also I can arrange the 7 electrons like this. Now I can arrange the 14 electrons in the molecular orbital like this. This is the arrangement of 14 electrons in the molecular orbital of the nitrogen molecule. So I can write the electron configuration like this: sigma 1s2, sigma 1s star 2, sigma 2s 2, sigma 2s star 2, pi 2py2, pi 2pz2, sigma 2px2. This is the electronic configuration. From this diagram it is clear that the number of bonding electron equal to 2 plus 2 4, 4 plus 2 6, 6 plus 2 8, 8 plus 2 10. The number of anti-bonding electron equal to 2 plus 2 4. So here I can write Na equal to 4. Bond order equal to Nb minus Na divided by 2. So here I can write 10 minus 4 divided by 2. That means 6 by 2 equal to 3. So there is a triple bond between two nitrogen atoms. So the bond order of nitrogen molecule is 3. Since the number of bonding electron is more than the number of anti-bonding electron, so nitrogen molecule is more stable. Since there is no presence of unpaired electron, all the orbital having 2 electron, so the nitrogen molecule is diamagnetic in nature. So here I can write the magnetic character is diamagnetic. Finally, I concluded that the bond order of nitrogen molecule equal to 3. Nitrogen molecule is more stable. Nitrogen molecule is diamagnetic in nature. This is all about for this class. Thank you. Have a nice day.